So I think DeFi is definitely coming back. I think the TradFi capital markets community is going to become probably the biggest user of DeFi and the public chain world. And I think RWAs, stablecoins, commodity coins, tokenized funds will eventually surpass cryptocurrencies in total market cap and go on to define what our industry is about in addition to cryptocurrencies. So I think the right thing for people to think about is how do they build applications that interact well with DeFi, interact well with TradFi, and utilize real-world assets and other forms of real-world collateral to back their applications and make them more reliable. I think that's kind of the future of our industry.
There's an increased presence of capital markets in this year's conference. Can you explain why SmartCon is a must-attend conference for leading institutions?
So Chainlink has created a standard for the Web3 DeFi community in the form of price feeds, proof of reserves, certain degrees of highly secure interoperability, some dimensions of identity, and now zero-knowledge proof usage to create identity. Those same technologies are very applicable to the capital markets. So the same technologies and parts of the Chainlink protocol that has been adopted in Web3 DeFi are now being adopted in the capital markets world. And we've had a lot of product leaders, technical leaders, and even CTOs of various large financial institutions here at the conference because they're starting to adopt those standards for how to manage data, how to manage identity, how to manage connectivity across chains, how to manage all of these complex issues that often result in key outcomes for them, like the ability to transact, the ability to comply, the ability to create tokens connected to key pieces of data. So the theme of this year's SmartCon conference is convergence between the DeFi community and the TradFi community. And the way that convergence happens is because both the communities are on the same standard, right? So if I'm a DeFi protocol and you're a TradFi user using a TradFi system, we'll need to agree on a settlement price. So we'll need to be on a standard to define price. Then we'll need to be on a standard to transact, for me to send you the asset, for you to send me the payment. And so what Chainlink is doing now, what the Chainlink community is doing, is expanding the use of the standard beyond its very widely adopted status in Web3 public chain DeFi and into the capital markets, benefiting the capital markets, but also benefiting Web3 DeFi by allowing the capital markets to interact and transact with the Web3 public chain DeFi world efficiently. So the conference really was full of people from Web3 DeFi and people from TradFi capital markets that are on the same set of technical standards that are now going towards transacting with each other. That's why they're all here.
Awesome. You also had a major announcement yesterday where you introduced Chainlink Runtime Environment, CRE. Can you describe the significance of this upgrade?
Yeah, it's an entirely new way of building smart contract applications across chains and across Oracle networks by composing the Oracle networks into chains using a single piece of code that runs in the Chainlink Runtime Environment. So the problem in the blockchain industry is that you have many different chains, you have Oracle networks, you have existing payment systems, you have identity systems outside of the blockchain, and these things are not able to interact in an easy to compose way. This is not that far from the situation that you had in the 1970s when the first mainframe databases appeared. There you had a technology called the COBOL runtime appear, where you ran a single piece of code to compose the different technologies of that time that just emerged when computers just became usable by institutions in the 70s. Then in the 90s, you had internet protocols appear, databases appear, all kinds of more advanced computing languages appear, and they needed an environment in which to run as well. And that environment had to serve the purpose of coordinating and interlinking all of those different components into a single application. Now we're in the same situation, but those new technologies are blockchains as a data structure, smart contracts as kind of pieces of computation that are spread across many blockchains, and Oracle networks as a type of decentralized microservice. What is going to compose all of these complicated separate systems into a single application? right? So what the Chainlink community has done very well is create the best decentralized microservices, the best Oracle networks for data, for identity, for connectivity across chains. But to compose all of those different Oracle networks into a single application still takes a lot of code and a lot of effort from developers. With the Chainlink Runtime Environment, what used to take months or weeks is now on track to take days or hours eventually, right? So the Chainlink Runtime Environment is the place where through actually existing languages like Go or TypeScript, eventually other languages are under consideration like Rust and others, you can now write code as a developer in a language you already know. That code can coordinate your contract across many different chains. It can deploy that contract on a primary chain like Ethereum. It can connect that contract to different Oracle networks. It can integrate that contract with the usage of Swift payment messages. And all of that happens in one piece of code running in one environment. That greatly simplifies the process of building an advanced smart contract, which is what the Chainlink community has been helping with for all the most advanced smart contracts, basically since the beginning of them, right? Of DeFi and of the trade finance and TradFi contracts. So this is really a very big step forward. I think people will believe it much more when they see it and when they see the power that it has. But I've already seen it take something that should have taken weeks and condense that down into a few lines of code that took hours for one engineer to write. So this is really where I think our whole industry is going. And a technology like this has to exist, and it has to solve this complexity across all these different systems. It has to happen. And the Chainlink Runtime Environment is now getting ahead of that and becoming the environment in which that happens.
So in addition to Chainlink Runtime Environment, how is the vision of the Chainlink platform evolving?
So the Chainlink platform became a very reliable data aggregation mechanism in the first years of its existence. It used a fundamental technology called Decentralized Oracle networks, which is basically a set of nodes that agree on something, but they don't agree on getting a block completed. They agree on things outside of blockchains. And the first category that the Chainlink system created this consensus agreement on was price data. Then it expanded to other types of data, becoming the largest provider of that data. Then it expanded to certain computations like automation or random numbers. And then it expanded to cross-chain connectivity. And all of those problems require the security created by the decentralized Oracle network model that Chainlink pioneered. And now Chainlink is evolving into all of those services, all of those data services, all of those identity services, all of those cross-chain connectivity services, as well as having a computing environment in which you can compose all those services together. That's the Chainlink Runtime Environment. So Chainlink is now evolving into an environment where developers can build advanced smart contracts by composing multiple chains, multiple Oracle networks into a single application. And Chainlink is in a unique position to do that because to build that advanced application, you need the Oracle networks, you need the data services, you need the identity services, you need the cross-chain connectivity networks that the Chainlink system has. But you also need an environment in which you can compose a number of those together and compose them together in relation to multiple chains, right? So you could have one contract, like your primary contract on a primary chain like Ethereum or an Ethereum L2, and then you want that primary contract on a primary chain to use multiple Oracle networks and utilize multiple chains in order to get the liquidity and the user base of that chain to interact with them. And this has to be created somewhere. This has to be managed somewhere. That's basically what the next evolution of Chainlink is. It's not just providing the Oracle networks that provide data and identity and connectivity across chains, but it's providing an environment in which all of those capabilities are composed together with multiple chains. And that is the code that defines a single application now that coordinates all of that complexity in that runtime environment, but still utilizes the blockchain for what it's good for the transactional activity of a blockchain.
Can you describe how capital markets can connect to DeFi using their existing systems?
Yeah, this is a long-standing problem that I've been working on for over 7 years through collaborations with existing large financial market infrastructures like SWIFT. I think this problem basically boils down to people reusing their existing signing systems, their private key signing systems, and their existing standards for communication among their existing systems. Swift messages are a good example. So Swift messages are signed by Swift private keys, which are, from what I can tell, the most widely used private key for signing high-value transactions. Swift private keys, I think, sign the most value in the world and have done so for something like 50 years. So you're reusing the Swift signing key, so this means people don't need to get a new signing device or a new signing method because the signing by the Swift private key is the same quality and same elliptic curve and same security, or in some cases better security than other signing keys. And then you're taking the existing Swift messages and you're reusing them as a method of interacting with a blockchain. So instead of getting 11,000 bank members in the Swift network or thousands of other members in other standards like FIX or others, why don't you let them sign a message that says, I want to execute transaction X on blockchain Y on smart contract Z. Then convert that message into a blockchain event, namely a signature that executes the transaction they want. Could be a buy transaction, could be a sell transaction, could just be a signature on a multi-sig, could be whatever. Could be a token issuance transaction, could be whatever transaction they want to do. Execute that transaction for them on the chain, return the proof back to them in the format they use, so they can keep using the format they use. There's no reason really to replace these formats or these signing methods. And the process of replacing them will create really big delays because people really need to understand that COBOL and Java Runtime Environment and all the existing messaging standards have continued to exist within the current financial system for literally 40, 50 years for a very good reason. And the reason is that these banking systems do not remove systems that control value. The big opportunity for the Chainlink, because there's risk and complexity, they just don't do it. The big opportunity for the Chainlink ecosystem is to solidify itself as the standard that layers on top of the existing systems. So the existing systems can be viewed as an onion layer with like COBOL and Java Runtime Environment and APIs and Node.js and other web languages. And now there needs to be another onion layer, which is the blockchain onion layer. There needs to be another layer that simplifies the interaction with blockchains. That's basically our approach. So our approach is a COBOL computation should be able to trigger a blockchain event. A Swift message should be able to trigger a blockchain event because they're going to keep using those technologies. So instead of pretending like they won't or trying to go down some weird path to replace them, just let them use the technologies they use, but make those technologies compatible with blockchains. Once you do that in a secure, reliable way, they can transact with blockchains. That's all we want. We don't really care if they use the old technologies. We care that they take the value in their system and they migrate it into a blockchain. That's all we care about. So let's just achieve that.
You also recently released a report on the use of AI and oracles. Why is that impactful for financial institutions?
Yeah, that's an interesting use case of the consensus created by Oracle networks. So the AI use case is where we ran multiple AI models in parallel in an Oracle network, and the consensus, the agreement created among nodes by the Oracle network, made the results of the AI models more reliable, and that allowed the data that the AI models put out to be relied on to control value. So just like the Chainlink Oracle network was utilized to aggregate price data for multiple price sources and create really reliable price feeds for DeFi that have not failed, that have kept it secure, that have kept it working through congestion, through flash loan attacks that never affected Chainlink, all these problems, right? That was able to happen because the consensus of an Oracle network aggregated results from multiple price sources into a single authoritative result that's difficult to manipulate and has high reliability. So similarly with AI, take multiple AI models, ask them the same question, aggregate their results, and eliminate the outlying results, or don't put in the answer that has too many outlying results as wrong. So that is actually pretty valuable because it gets AI maybe past the 98% reliability or accuracy threshold and gets it to the 99% threshold of accuracy, which makes it usable for certain use cases that it wasn't usable for before, and allows it to provide results that can control value. So Chainlink generally creates Oracle networks that are related to value, providing price data that controls value, providing identity that triggers the movement of value, connecting Swift messages to blockchains to allow value to move. In this case, it was the application of Oracle networks to create agreement among AI models, different models, and create a greater reliability for the answer, and therefore allow the answer to control value. Similarly to how Chainlink has done that for many other data sets like price data. So that's what we did, and it's exciting because AI has gotten to a very good point where it can take data that's unstructured, that's not usable to trigger outcomes, and it can structure it and make it kind of machine readable. And so that's the data we did this on. We did this on what's called corporate actions, which are unstructured data that's hard to understand sometimes, and generated a highly reliable result.
What's the significance of enabling institutions to preserve privacy while transacting on-chain?
Institutions are used to having privacy, and they actually have legal requirements that mean they legally have to have privacy for their transactions. And in the cases where that isn't the reason they want it, there's lots of strong economic reasons why they want privacy. So if you don't provide privacy for identity data, for transactional data, for a number of other aspects of the transaction won't happen. And our goal is to make the transaction happen, because when the transaction happens, more value flows into our industry. That's kind of what we should be asking ourselves. How do we solve the problems of the institutional world to get them to transact on blockchains? And privacy is one of those gating fundamental problems. I'm very proud to say that now the Chainlink community has started seriously solving this problem. We've created a blockchain privacy manager that can be wrapped around the blockchain to control what information is private as it enters and leaves the blockchain. We've then applied that blockchain privacy manager to CCIP to create something called CCIP private transactions. That is very useful, and even here at the conference you had ANZ and Anurag from ANZ, the product lead of digital assets, explaining that that's a critical component for them to be able to transact. So now you have a privacy manager, you have a cross-chain way to do privacy, a privacy-preserving cross-chain transaction. And then the third technology that went live today after many years of development was DECO. DECO is a zero-knowledge proof-based technology that can verify information off-chain and provide the proof of that information on-chain. So this means you can ask the DECO system, what is the location of this person in a sanctioned country? Are they above a certain age? Do they have enough money in a bank account to be considered an accredited investor? Very basic compliance questions that you would need to have answers to in order to allow that value to interact in a compliant way with an application in the traditional world. Now what you can do is you can verify all that using zero-knowledge proofs. You can check that all those conditions are met. You can return the proof that they are met back onto the chain, but you can keep the detailed information private. So you can prove that the compliance requirements are met by the identity, allowing the transaction to continue, allowing the value of that user to flow into the system, but you keep the details, which is what really needs to be private. So it creates a way to keep key information private while providing enough information to allow compliance and the use of the information by a blockchain. That's a very exciting development. I think there will be many more developments from the Chainlink community about how to create privacy around confidential computation, various other capabilities through the Chainlink Runtime Environment. And all of that will add up to being able to create truly private transactions across chains and to inject pieces of data in there that are only usable if they're private, like identity data. So that's where I think the Chainlink community will continue to have a big impact.
So speaking of developments, what other innovations are you most looking forward to over the next year?
So the Chainlink Runtime Environment is very exciting. We're already using that with a few use cases that are planned for kind of pre-production live trial stage at some point. So we're working through the CRE to make really complicated use cases possible. That's very exciting. Beyond that, the privacy capabilities are going to be very useful and important. And I've already seen a lot of adoption and interest of the privacy capabilities that we've started putting out in the Chainlink community. Beyond that, I think CCIP, the cross-chain system, is continuing to develop pretty rapidly. It's continuing to be chosen by many chains as their canonical native bridge technology. So it's being chosen by them as the native bridge of that chain. And so that speaks to the security it provides. And there's more security features and more speed features and more kind of integrations into more chains. So it's more widely connected. I think those are three of the biggest things. And then there's always a continual flow of more data. There's always a continual flow of more kind of low latency data. So Chainlink has just gotten really, really good at providing all the data that the DeFi community needs and now that the TradFi community needs, whether that's low latency data, price feeds, reference data, NAV data, AUM data, just entire new categories of data are appearing on Chainlink as they get adopted by all these smart contracts. So I would say those are the main exciting developments.
What factors are driving the adoption of blockchain technology among traditional finance players?
It's actually a very exciting time because the asset management industry, the buy side, is what's really driving adoption at this point. And that's a very good historical pattern. So the buy side, the asset management industry, together with asset owners like sovereign wealth funds or family offices, are basically the two groups that the rest of the traditional financial system services. Banks, financial market infrastructures, various service providers, basically provide services to make asset managers buy or use their system, and the asset managers fundamentally serve asset owners. So the asset owners and the asset managers, the buy side, have the purchasing power, which means they have a lot of influence. And now the asset owners and the asset managers have started to adopt tokenized funds. BlackRock's BUIDL is a good example of this. This adoption of tokenized funds by the asset management industry basically sends a very strong signal to the rest of the financial service stack, the banks, the financial markets infrastructures, the central banks, that they are going to have to provide services in a blockchain format. And this dynamic is very, very positive and has never existed in our industry before. And it's literally appeared basically this year. And I think it's only going to accelerate next year. In addition to that, there's all kinds of efficiency gains. There's better collateral management. There's all kinds of huge benefits, efficiency benefits that massively reduce the costs of operating and managing financial products. There's all kinds of risk management benefits, making the financial products clear and understandable without having to have a data subscription because the data about the product is in the token itself. There's all these risk management benefits as well. But the strong economic force that's pushing the adoption and real implementation of blockchain technology, the capital markets TradFi world, is now the buy side, which is very good because that is basically the best group that you could have pushing the adoption of your technology. And when you talk to people that have spent 20, 25, 30 years in the capital markets and seen the historical trends, when the buy side starts pushing a new trend or a new technology or starts adopting a new asset type, it usually has a very quick and very positive uptake by the rest of the industry. Now what we really need is a set of standards and a good computing environment in which those standards can be composed together with many different chain technologies into a single unified application. That's the thing that I think everyone needs.
Yeah, speaking of that, key technologies, what other integrations are essential for banks aiming to adopt digital assets on a scalable, sustainable basis?
Sure. So to make a financial product, you generally need data to prove things about the financial product. The financial product needs to guarantee certain levels of privacy, and the financial product needs to have distribution or access to users that are going to purchase it. If you look at it from that point of view, the financial products that happen on chain need data oracles, so oracle networks that provide various key pieces of data, price data, NAV data, AUM data, all kinds of data. Then they need to preserve privacy in order for them to come into existence at all. This is where you need like a blockchain privacy manager, private cross-chain transactions, private identity data coming in, proving things about the identity. So you need privacy of certain key parts of the transaction. Then for distribution, you need access to all the places where users will interact with the financial product. Historically, the way this has been done is I'm going to launch in a chain. So I launch my RWA or I launch my cryptocurrency in a chain, and I get the user base of that chain. That's the user base I have. I'm not going to have a larger user base. With interoperability from cross-chain systems like CCIP, now you have the ability to launch in one chain, but have the user base of all the chains, which is, by the way, how the internet works. The internet doesn't work that you launch your application in the Amazon Web Services cloud, and you can only interact with the other websites and the other users in the Amazon Web Services cloud. That's not how the internet works. The way the internet works is you launch your application in whatever cloud you want, whatever database you want to use. So you can use whatever data structure technology you want. And then through a set of protocols, you get interconnected with all the other databases and all the other clouds and all the other computing environments because you're on the internet. So let's say you make a financial product with data. Let's say you make a financial product with privacy. Great work. That's like wonderful. Now you've done all this work in order to make it successful by users buying it. Great. You can, assuming you can maintain privacy and assuming the data can reach the financial product in your chosen chain, which is what Chainlink has been doing so far, is providing that capability to various chains. Your next question is, how do I get all of the users I want to interact with the product? That's where you need a cross-chain system that's efficient and secure. And then once you really look at all this and you're like, wow, I got to get data working, I got to get privacy working, I got to get connectivity working, you kind of go like, wow, this is a lot of work and I wish I could just do this through a single piece of code. That'd be really nice. And that's when you need a runtime environment in which you run a single piece of code. That single piece of code coordinates all of these oracle networks, all of these data sources, all of these privacy capabilities, all of these chain interactions into a single application. So I think that that is, really the model in which advanced applications are going to be built, because historically that's the model in which applications are built in the rest of the world. History kind of just tends to repeat itself, right? And so I think what we need to do is look at kind of the facts of life and say, hey, okay, banking systems are not going to get rid of Swift, Fix, or other messages. People want a runtime environment. You need reliable data sources. Let's just provide all that to the various developer communities, give them a runtime environment in which they can compose it efficiently, and have them build really great applications that provide a lot of value very quickly. Like, that's what I think we should do.
Perfect. So to wrap up, do you have any final words you'd like to share with our audience?
So I think DeFi is definitely coming back. I think the TradFi capital markets community is going to become probably the biggest user of DeFi and the public chain world. And I think RWAs, stablecoins, commodity coins, tokenized funds will eventually surpass cryptocurrencies in total market cap and go on to define what our industry is about in addition to cryptocurrencies. So I think the right thing for people to think about is, how do they build applications that interact well with DeFi, interact well with TradFi, and utilize real-world assets and other forms of real-world collateral to back their applications and make them more reliable. I think that's kind of the future of our industry.
Sergey, it was great to catch up. It's been really interesting to see the evolution of Chainlink throughout the years, and looking forward to what comes next.
My pleasure. Thank you.